Hello guys, welcome to Big Book. Today we are going to discuss the estimation of the amount of hydrochloric acid using standard zero point 0.1 normality sodium carbonate solution by titration method. Now we will discuss the principle under this titration method of estimation of amount of hydrochloric acid with the standard 0.1 normality sodium carbonate solution. So here you can see that it's a two-stage reaction where I have quoted a equation, chemical equation of the reaction, that is sodium carbonate aqueous, hydrochloric acid aqueous gives rise to sodium chloride aqueous and the carbon dioxide and water. That is the end result. Now here this is the two-stage reaction where first stage is that when we are going to add hydrochloric acid solution to a solution of sodium carbonate, the hydrogen ions in HCl switches places with one of the sodium ions in sodium carbonate to produce sodium hydrogen carbonate, also known as sodium bicarbonate, that is the baking soda and sodium chloride salt. Now here, as per this discussion, if you see the chemical reaction equation, that is the sodium carbonate plus HCl aqueous gives rise to sodium bicarbonate plus sodium chloride aqueous. So this is what the reaction. So this sodium bicarbonate, it is again readily going to react with the HCl if the HCl is present in excess within the medium. That is, sodium hydrogen carbonate or the bicarbonate present is basic in its nature and it reacts with the HCl still in solution to produce sodium chloride, carbon dioxide and water. Now here you can see the last equation, that is the sodium bicarbonate, HCl, sodium chloride, carbon dioxide and water. Now here this is the two-stage reaction. The first stage is that it gives rise to the sodium bicarbonate and the second stage is that it gives rise to the sodium chloride salt. First is the sodium bicarbonate salt, or it again called to be as the sodium hydrogen carbonate salt. Now in the second stage the end product is the sodium chloride. Now here these first stage equation and the second stage equation combinedly forms this one equation. Here you can see this first part of this equation is here and the second part of this equation is here in the second equation, here in the red. Now here if we are going to see in many of the explanations, either it can be in your lab manuals or in your textbooks, there they will give this single equation to make it very precise and comfortable in the understanding. So I have taken it quite elaborated form of the principle to make you to understand the things which will happen within the medium. So this is the principle of this particular estimation of the amount of hydrochloric acid using standard 0.1 sodium carbonate solution. Well, in this slide we are going to discuss the procedure for the experiment. In this the first step is that exactly we are going to take 25 centimeter cube of the n/10 sodium carbonate, which will be pipetted out into a clean conical flask. Then we are going to add 2 drops of indicator solution of methyl orange. The solution turns yellow. So here whatever the titrator titration is that where this sodium carbonate will be titrated against HCl acid taken in burette till the yellow solution turns pale orange red. Then we are going to, so that reaction of the turning of the or changing of the color, it is because of the response to pH changes associated with the formation of NaCl, changing from yellow to red as the solution becomes more acidic. At neutrality, it is a distinct orange color. So at a particular neutrality where molar weights of both the compounds of HCl and sodium carbonate is going to be 1:1. So at that neutrality, the distinct orange color is going to be seen. The burette readings are tabulated for the calculations. Now here this step of from the first, taking the 25 centimeter cube or cc of the sodium carbonate into conical flask, this has to and adding drops and again titrated as against the HCl and getting the distinct orange color. These steps we have to, these titration steps we have to repeat for 3 times, and we have to make the note of the initial reading of the HCl in the burette and the final reading of the HCl in the burette, and we are going to make we are going to make the tabulation of this particular burette readings separately. Now here this is the calculation part or the slide where we are going to see this particular table is the tabulation of the burette readings. Here we are going to take the initial reading, here the final reading. For the second time repetition, initial reading here, final reading here. For the third time repetition, initial reading here and the final reading here. So we are going to minus the initial reading with the final reading, and we are going to take the total here. In the same way for the second repetition, for the third repetition. Here why we are going to take 3 repetitions, it is to make sure that we are getting the, we are doing the titration in the exact form, and we are getting the nearest value of the HCl flow down, so that the neutrality can be exactly bought. And in the here in some colleges or labs, all the 3 will be considered. Whatever the volume of the HCl has been flowed down, all the 3 will be considered and the mean will be taken. In some labs or the colleges, only the second and the third will be taken and the mean will be considered. So here mean value of second and third is taken, which will be the x, because here we have taken the blanks just to make the calculation very clear. So further, after getting this mean value, we are going to substitute this mean value or the volume of the HCl or mean value of the HCl has been flowed down into the formula, where V1N1 is equal to V2 N2. It means volume of the first solution and normality of the first solution is equal to volume of the second solution and the normality of the second solution. So here the first solution is HCl and the second solution is the sodium carbonate. Here HCl, we are estimating the amount of the hydrochloric acid. Here we have taken the HCl in the burette, but here we don't know the normality of the HCl because we don't know what the mass of the hydrochloric acid. So here we are going to consider only the volume V1, which is the mean value of the HCl rundown through the burette, as x. So for the V1 we will take x. If you are going to take this formula in the lab or in your college practicals, you will get the readings. So you are going to take the readings here instead of x into n1 is equal to 25. 25 is that the volume of the sodium carbonate which we have taken to titrate against the HCl, and the normality is the 0.1. Already we have mentioned here in the title itself. So here the formula is going to further make a in this form, that is the V1N1 divided by the V2N2 divided by the V1. So 25 into 0.1 divided by the x. So whatever the normality we are value we are going to get, that is the normality of the HCl solution. With the help of the normality of the HCl solution, we are going to calculate the amount of the hydrochloric acid has been used. So here for that we are going to take the equivalent weight of the HCl, which is again the molecular weight that is 36.5. Now further, this mass of the HCl per decimeter cube of the solution is equal to normality into gram equivalent weight. Whatever the normality we got here, that will be multiplied to 36.5, that is the molecular weight. So whatever the value we are going to get, that will be the estimated amount of the HCl has been used in the solution or in the experiment. So this is how we are going to estimate the amount of the hydrochloric acid using standard sodium carbonate solution.